Our setup for the Chladni plate was pretty simple. We simply attached a rod to the voice coil of the speaker, and then attached the plate to the rod. And this is what our Chladni plate looks like without the plate.
This is a quick review of standing waves. Here we have a one-dimensional representation of a standing wave, such as a wave on a string. This is a node where the minimum displacement occurs. And here's an antinode where maximum displacement occurs. When you switch to two-dimension, like you would on a Chladni plate, nodes become lines, called nodal lines, and they're represented here by all these lines. And these areas of white are essentially the same as here, but mathematically we do not know where the antinode is here.
This is the one-dimensional setup of a standing wave. As you can see over here, like in the example shown in class a while back, where there's a string fixed at one end and a transverse wave traveling across it. Once the wave reaches a fixed end, assuming the wave is being continually sent out, it reflects back, and the continually sent out wave and the wave being reflected back will constructively and deconstructively interfere with each other for a while. After a while, the troughs and the troughs and the crests can line up together, resulting in a standing wave that is completely constructive interference, resulting in a standing wave where the amplitude is twice that of the original wave. This is a setup of a two-dimensional standing wave, and it is very much similar to the setup of a one-dimensional standing wave. If you can imagine a pebble being dropped in a pond, a very small pond that has walls that are close by, it will send waves or ripples out, and then they will reflect back and interfere constructively and destructively with the initial waves being sent out from the pebble. So what is with the Chladni plate, the side view of the Chladni plate here, there is a point where it's connected to the speaker and is vibrating at a certain frequency, and it is sending out waves from that central point, it is sending out waves from that central point. And they will hit the surfaces over here. This is a gross oversimplification, but they will reflect back, and they will interfere destructively and constructively with the waves. It is possible to get the nodal lines from an equation for a Chladni plate. Thing is that our shape was not one of the ones that they had an equation for, since there is a different equation for each shape, because it will reflect differently and behave differently for each plate. But we can use the equations for other shapes to show you what's going on. This is the equation for a square plate that's fixed in the middle, and what we care about is the m and the n. I'll tie the physics in a bit. Now the m and the n can mean different things. They are in each of the equations. For instance, here is a circular plate, and for the circular plate equation, which I don't have up here, It means radial and diametric. For some reason, they decided to call the circles radial. But anyway, the M is the number of circles, and the N is the number of diametric nodes. And over here with the rectangular Chladni plate, the M and the N's are the rows and the columns. And that's it. Okay, to relate M and N to physics, I go to the relation frequency is related to M and N. Now this is different for each plate just as the equation is different. For instance, for a circular plate, F is related to N plus 2N squared. And for a square plate, F is literally equal to the square root of, I'm not going to say the rest, you can read it. And now, what this means is that as F increases, either M or N must increase, meaning that the higher the frequency, the more of these nodal lines you will get of either M or N in type. And how this can be related to an equation that we can understand, as this is slightly confusing to me, is V equals F lambda. Now, since the sound is traveling, the vibrations are just traveling through the plate, the speed of sound is not going to change as the medium is not changing. And there are things that can cause a change in speed, but the medium is not changing, V is constant. What that means is in order for, let's just assume V equals 1, in order for it to remain 1, if frequency goes up, lambda, a wavelength, has to go down. And what that means is, as you can imagine with this picture over here, the more of these lines that are there, the more points at which constructive and deconstructive interference can occur, meaning more nodal lines.
Now, as stated earlier, frequency is related to M and N, meaning that this is a direct relationship, meaning that as frequency goes up, M or N have to go up. Now, here's an example for a circular plate, where F is related to M plus 2N quantity squared. Now, here are examples of what happens when the frequency goes up. Now, if N increases due to the frequency, we will see more diametric nodes. If M increases due to the frequency increasing, we will see more radial or circular nodes. Now, when M and N both equal 0, as you can see, the plate will be completely blank and devoid of any pattern. The following is another person's example of this in practice.
It is regrettable to say that several speakers were harmed in making this film, including one subwoofer, 5 speakers, and 1 karaoke machine. Let us have a moment of silence for the lost speakers.
Relax, all right? My old man is a television repairman. Got this ultimate set of tools. I can fix it.
You can't fix this car, Macaulay.
I can fix it.
Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening, but they fought with expert timing. There were funky Chinamen from funky Chinatown. They were chopping them up, they were chopping them down. It's an ancient Chinese art, and everybody knew their part. From a fainting to a slip, and a kicking from the hip. Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening. Yeah, but they fought with expert timing. There was Funky Billy Chin and Little Sammy Chung. He said, here comes the big boss. Let's get it on. We took a bow and made a stand. Started swaying with the hand. Sudden motion made me skip. Now we're into a brand new trip. Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening. But they did it with expert timing. Oh, yeah. Keep on. Sure, everybody was kung fu fighting.